Assalamualaikum and hello everyone. We are third year students from Manufacturing Engineering taking Integrated Design Project who would like to present our product which is called Automatic Fruit Peeler. This video is prepared for our panel and our supervisor. My name is Siti Suzana binti Mohammad. I will start the presentation with the problem statement. The problem statement of this project is when the peeler in today's market are manual working design and it requires both hands to operate it. When we use our both hands to peel the skin of fruit, it will consume more energy, time, and at the same time, it can cause injury. Besides, the current peeler also not efficient because the item can easily lose. Now we move to the objective. The first objective is to improve on current peeler product by introducing automatic design, which means we improve from manual design to automatic design that will be more easier to the consumer. Second, to design and fabricate product that will improve efficient on amount of peeled fruits according to the customer needs. Next is methodology. After all the criteria and specification had been identified, it can be applied in a chart that known as morphological chart. The chart consists of selection criteria and 5 option design. This is our conceptual design. There are 5 conceptual design for early phase to develop design during the brainstorming session. This is screening and scoring concept. It has been distributed based on the priority criteria from the feedback. The concept with the higher ranking with the candidate has been selected, since it the most satisfied and will be designed using Autodesk Inventor software.
Hello, I'm Philip Patrick, so I'm going to continue the presentation. So now I'm going to talk about the working principle of the product. To start, you can simply just press the push button on the left side. The movable top pin can be used to adapt to different height of the fruits. So the robotics arm can move in balance so that it can keep the thickness uniformly. So the peel skin we move on the left side, which have we provided in our design to keep the peel skin organized so that it can be easily be cleaned. So now I'm going to talk about the mechanical engineering analysis. For our product, we have chosen two types of mechanical engineering analysis, which are the material analysis and the structural analysis. For the material analysis, we have chosen the CS EduPack software to develop to analyze the suitable material for our body and pillar blade. So now I'm going to talk about the material choice for the body. We have selected 5 different material to be selected for the body. This function is to give the overall look of the product. It must have the very good high strength, low density, and have good fatigue failure for long term and adequate fracture toughness. So after we have selected the design requirement for the body, we're going to the scoring and screening to get the best material. So from the result above, you can see that the ABS plastic is chosen based on its highest total points among the other two. So now I'm going to talk about the choice for the pillar blade. Pillar blade is one of the most important component in the product. We have chosen 4 different type of material to be selected for the final material. So it's good to have a very high strength, adequate fracture toughness, corrosion resistant, have a good corrosion resistant, and good to resist fatigue failure for long term. It also good to have a very small mass for the pillar blade. So after from the result, you can see that the stainless steel is the best material for the pillar blade.
Alright, the next part is regarding the element analysis, which is going to be presented by me, Mineshvaran, and my metric ID is B0518101139. Okay, I'm going to talk about the load that is acting on our product. As you can see in the image above, the load is at the bottom part where the fruits or the vegetables will be placed. So the explanation regarding the total load acting are, which is the load by the motor and the battery, 4 AA batteries, and the battery holder is assumed to be around 400 gram, and the average load by the fruits and vegetables, the sizes may vary, is assumed by fruits goes for a 50 gram, vegetables goes for a 265 gram, so the total there is assumed to be say around 315 gram. So by adding the forces, we can get the total forces as assumed force for fruit, where 400 gram plus 50 gram is 450, and the assumed force for vegetables is 400 plus 265, so it's It goes by 665 gram. Next, we are going to talk about the maximum stress and the minimum stress. So the maximum normal stress acting is 12.7 megapascal. Meanwhile, the minimum normal stress acting is 13.09 megapascal, as you can see on the images uploaded here. Next is the safety factor. The safety factor is derived by the ultimate tensile strength over minimum stress. So 26.18 megapascal over 13.09, which is the minimum stress, as we can see before. So the safety factor is derived as 2. Next is the displacement analysis. The maximum displacement value of each displacement, the deflection acting, is 0.1479 mm, which is very small and unnoticeable with naked eye. It is considered as a very tiny thing. Next is the observation of our product analysis. So the depth of cut for both is 0.1. So the top picture is the potato and second is the apple.
Hi everyone, I'm Ooi Shen Zhuang. Today, I would like to continue the presentations with process flow of our product. Firstly, the process starts from the raw material, then continue with shaping, joining, and finishing. For shaping the plastics, injection molding is used to produce the plastic parts. There are total 4 parts, which are clamping, injection, cooling, and ejection. The raw plastic materials is fed into the injection molding machine. Then the molded plastic parts starts to cool down in the mold. After cooling, the cool plastic parts will be ejected. Next, the automatic foot peeler is made up of different parts, which are body, tray, assembly height, brake, topping, and the holder. So, to join the part, mechanical joining is used. It is a core-forming technique. Bolts and nuts are used here to join two parts together and to make the fastening process more effective. Lastly, for finishing, coatings are applied. As we know, coating is applied as it is resistant to surface chemicals, scratch, and abrasions. Okay, let's move on to the cost analysis. We have done 7 analyses on variable cost, fixed cost, production and manufacturing cost, profit margin, selling price, unit contributions, and break-even analysis. So here is the results that we obtained. By the way, to obtain the production and manufacturing cost per unit, we have assumed 150 products to be produced per month. Next, the margin that we use is 15%, which in the end we get 20 ringgit and 70 cents. Throughout the calculations, we obtained around 254 units for the break-even analysis. Okay, that's all for my part. Thank you.
Hello, my name is Ambrosius Herman and I'm the last presenter for this group. Today I will talk about the sustainability. In sustainability, there are 2 chapters we need to reconsider. The first one is eco-design and the second one is eco-indicator. In eco-design, this is the 6th part that we need to consider before we proceed to the next step. After we consider the 6th part, this is the eco-design way that we can get. Okay, for the first eco-design web is for the electric component, and the second one is eco-design web for stainless steel, and the third one is eco-design web for the plastic ABS. For eco-indicator, the value that we need to find is production of the product, the process of the product, the amount used of the material, and the disposal of the material for each part. After we calculate, the total for our eco-indicator for this product is 313.229. According to the definition of eco-indicator, if the value of eco-indicator is high, it means it will have a negative impact for our environment. For summary, I will talk about the benefit, the target audience, and the cost for this product. The benefit that we can get by using this product is to reduce time consumption and energy when peeling the fruit or vegetable, and it also can prevent any injuries when using the peeler. The target user is focused on more on SME or the household people, and the final cost for our product is 158 ringgit and 70 cents. That's all from our group. Thank you.